early July of 2025, and astronomers at the Atlas telescope in Hawaii are staring at their screens, hearts pounding. What they've just spotted isn't your everyday asteroid or comet. It's something barreling in from the depths of interstellar space, a rogue visitor from another star system, hurtling toward our sun at speeds that defy imagination. They name it 3I divided by Atlas, the third confirmed interstellar object ever detected in our solar system. But here's where it gets truly eerie. This alien wanderer isn't arriving alone. Right around the same time, a cluster of 7 comets from our own cosmic backyard starts lighting up the skies, all converging in a spectacular display set to peak in October. Could this be mere chance? Or is something or someone orchestrating a celestial rendezvous? What if these icy intruders are harbingers of an invasion from beyond? Probes disguised as natural phenomena, signaling the start of something we can't even comprehend. Hold on, let's not jump too far ahead. Before we dive into the wild theories swirling around this event, picture the scene unfolding in observatories worldwide. Scientists are buzzing with excitement and a touch of unease. The interstellar object, 3I divided by Atlas, was first glimpsed on July 1st, 2025, when it was still about 670 million kilometers from the Sun, farther out than Jupiter. Unlike anything born in our solar system, this thing carries dust and ice forged around a distant star, perhaps millions of years ago, before drifting through the void until gravity from our Sun snagged it. Early observations show it's developing a fuzzy coma and a tail unusually early, as if it's eager to reveal secrets from its home world. Astronomers are calling it potentially the oldest comet we've ever seen, its composition hinting at exotic chemicals like carbon monoxide and methane that vaporize at frigid temperatures. But why now? And why alongside this swarm of local comets that seem to be putting on a show just for us? Now, let's talk about that swarm 7 comets, each with its own story, but all timing their grand entrances like performers in a cosmic ballet. Take Comet Swan, or C divided by 2025 R2, discovered just days ago on September 12th by the Solar Wind Anisotropies instrument aboard a spacecraft studying our Sun's particles. It's already glowing with a hydrogen envelope, brightening faster than expected, and by October it could reach magnitude 7.5, visible through binoculars low in the western sky after sunset, right near Mars. Then there's Comet Atlas K1, another fresh find from the Atlas survey, expected to skim close to the Sun at just 0.3 astronomical units in early October, potentially flaring up dramatically as its ices boil off. Add in Comet Lemon, or C divided by 2025, a 6. From the Mount Lemmon survey in Arizona, which might hit magnitude 7 and linger for weeks, offering Northern Hemisphere viewers a treat with its dusty tail stretching across the stars. But wait, there's more to this lineup. Comet Pan-STARRS, caught by the panoramic telescope in Hawaii, promising naked eye visibility from late March through May next year, though its path aligns suspiciously with the swarm's peak. Stereo, spotted by solar observation satellites, dives perilously close to the Sun, risking disintegration in a blaze of glory. Atlas G3, sibling to K1, adds to the family affair with its own binocular-friendly glow. And NEAT, a legacy from the Near-Earth Asteroid Tracking Program that wrapped up years ago, but whose orbit was plotted so precisely that we knew it'd show up now. Rounding out this septet, 7 comets, all from the distant Oort cloud or Kuiper belt, regions of frozen relics left over from our solar system's birth 4.5 billion years ago. Normally, we'd be lucky to spot 1 or 2 bright ones in a year. But here they are, crowding the calendar like uninvited guests at a party. The odds? Astronomers crunching the numbers say this kind of clustering happens maybe once every 1,000 years, pure statistics from random orbital mechanics. Yet, whisper the conspiracy theorists, what if it's not random? Online forums are exploding with ideas. Perhaps an unseen force, like a rogue planet's gravity, nudged them all inward at once. Or electromagnetic pulses from our sun's peak activity in its 11-year cycle solar maximum, hitting right now in 2025, somehow herded them. And then there's the wilder stuff. Could 3I divided by Atlas be an alien artifact, a probe sent to scout our system, with the comets as decoys, or even engineered companions? After all, the first interstellar visitor, Oumuamua, back in 2017, sparked debates about its cigar shape possibly being artificial. The second, Borisov in 2019, looked more like a comet, but still raised eyebrows. Now this third one, larger and brighter, arriving during our busiest comet season in memory. Coincidence or cosmic signal? As we unpack this mystery, it's hard not to feel a thrill. These comets aren't just pretty lights. They're time capsules. Each one drags a trail of gas and dust that tells tales of ancient solar winds, planetary formations, and even the building blocks of life, organic molecules that might have seeded Earth. 3I divided by Atlas takes it further, offering a glimpse into another star's nursery, its spectrum revealing isotopes and compounds we don't see here. Scientists at NASA and the European Space Agency are scrambling telescopes like Hubble to capture every detail, while amateur stargazers worldwide share time-lapse videos on platforms like X, showing tails flickering against the backdrop of auroras amplified by solar storms. It's a reminder that our universe is alive, dynamic, and full of surprises that don't need extraterrestrial plots to captivate us. Speaking of sharing, if you're hooked on this cosmic drama like I am, why not hit that like button? Subscribe for more episodes diving into the stars, and drop a comment below with where you're tuning in from and what time it is there. Whether you're under the Southern Cross in Australia at midnight, or catching the dawn in New York, your stories make this journey even more exciting. Let's build a community of night sky enthusiasts together. Now, back to the intrigue. What makes this swarm feel so orchestrated? Picture the data plot's dots scattered across years like random rain, but in 2025, 7 clump together in a tight window. Forums buzz with images of multiple tails streaking the same sky patch, videos of what looks like a synchronized dance, and 3I divided by Atlas, with its hyperbolic path a one-way ticket through our system, slinging around the sun and out forever aligns its closest approach precisely during this frenzy. Skeptics point to improved tech. Surveys like Pan-STARRS and Atlas scan the skies every few nights, spotting fainter objects we'd have missed before. But that doesn't explain why these particular comets, with orbits set eons ago, chose now. Solar maximum adds flair our sun's magnetic tantrums, ejecting billion-ton plasma bubbles that twist comet tails into knots or sever them entirely, creating illusions of coordination as all respond to the same stellar outbursts. Yet, for those awake at night pondering, the timing nags. An interstellar stranger, forged in alien fires, seasoned by cosmic rays over millennia, sinking with our local ice chunks. Is the universe whispering about interconnected forces we haven't grasped, like subtle gravitational waves rippling from distant events? Delve deeper, and the science shines through the speculation. Comets brighten by magnitude, a scale where lower numbers mean brighter sights. Magnitude 6 is naked eye limit in dark skies. Our swarm promises several dipping below that, rivaling stars. Perihelion, that closest sun swing, turns ice to gas in spectacular jets. But for 3 I divided by Atlas, happening at a modest distance, it might not vaporize completely, preserving clues for spectroscopes to decode. Ground rules here. We'll tag wild ideas as speculation, sticking to verifiable orbits and brightness logs. If connections exist, they'll show in data timing beyond probability. Shared perturbations. So far, independent paths, natural evolution under sun and planet's pull, but the pull of mystery lingers. Imagine if this isn't coincidence. What forces could align such vast scales? Gravitational shepherds like Jupiter carve asteroid belts. But nothing matches this. Electromagnetic fields shape tails, not trajectories. Exotic physics, speculation, yet thrilling. As 2025 unfolds, with solar flares painting skies and comets streaking through, we're witnesses to a rare parade. It reshapes how we see our neighborhood, not isolated, but part of a grander web where visitors from afar remind us of the unknown. Stay with us as we meet each comet up close, unravel the stranger's secrets, and chase the truth behind this sky full of intruders. The universe is calling. Will you answer? Let's peel back the layers on this cosmic gathering, starting with the star of the show that's already stealing glances from backyard telescopes around the globe. Comet Swan, officially tagged as C divided by 2025 R2. Discovered just over a week ago, on September 12, 2025, by the Solar Wind Anisotropies instrument. A clever piece of tech orbiting Earth to study our sun's invisible breath. This comet announced itself with a subtle hydrogen glow, like a whisper from the outer edges of our solar system. It's not your typical slow burn visitor. Swan is ramping up brightness at an unexpected clip, already visible through binoculars near Mars in the evening sky, low in the west after sunset. By October, experts are whispering it could dip to magnitude 7.5, making its tail a shimmering veil of gas and dust stretch like a ghostly finger across the constellations. What keeps me up at night pondering is how Swan seems almost too prepared for its debut, outgassing hydrogen months ahead of schedule, as if it's carrying secrets from the Oort cloud, that distant icy reservoir where comets slumber for eons before some gravitational nudge sends them plummeting inward. Could a distant stellar encounter have stirred this one awake? Or is it just the universe's way of reminding us that even frozen rocks have stories to tell about the chaotic birth of planets? Shifting our gaze to another fresh face in this lineup, Comet Atlas K1 or C divided by 2025 K1, if we're being precise, emerged from the vigilant eyes of the Atlas survey in Hawaii, a network of telescopes that scans the heavens every few nights, like a cosmic watchdog. Spotted back in May, this one's a newcomer from the Oort cloud too, but with a daring path that brings it perilously close to the Sun on October 8th, at a mere 0.3, 3 astronomical units, that's about 50 million kilometers. Close enough for intense solar heat to potentially crack its nucleus and unleash a spectacular outburst. Imagine the drama. As it swings in, the ice sublimes into jets of gas, propelling dust particles that could make its tail fan out dramatically. Visible, perhaps even to the naked eye, under dark skies. What's intriguing here is the timing, why this comet, with an orbit that might span thousands of years, aligns so neatly with the others. Data from NASA's Jet Propulsion Laboratory shows its trajectory was set long ago, influenced by subtle tugs from Jupiter or Saturn, but the coincidence sparks questions about hidden resonances in the outer solar system. Invisible waves that cluster these wanderers, like leaves in a stream. And if it fragments under the sun's glare, as some comets do, we'll get a front-row seat to fresh interior materials spilling out, offering clues to the primordial soup that birthed our worlds. Organic compounds, perhaps even precursors to life, frozen since the dawn of time. Now, let's turn to Comet Lemon, or C divided by 2025, a 6, named after the Mount Lemmon survey in Arizona, where astronomers have been hunting sky oddities since the 1990s. This one popped up in their data earlier this year, around January, and it's shaping up to be a steady performer, likely reaching magnitude 7 by late September, and hanging around through October for observers in both hemispheres. Unlike the Daredevil's diving sunward, Lemon takes a more measured approach. It's perihelion at a safer distance, allowing its tail to develop gradually a dusty arc that might curve gracefully under radiation pressure, the gentle push of sunlight on tiny particles. The curiosity factor ramps up when you consider its position in the swarm, smack in the middle, neither leading nor trailing, as if holding the formation together. Spectroscopic readings from ground-based observatories like those in Chile reveal water, ice, and carbon dioxide dominating its makeup, standard for solar system comets, but with hints of unusual isotopic ratios that could trace back to specific formation zones in the Kuiper Belt. What if this comet's journey encodes a map of ancient migrations, nudged by Neptune's gravity over millennia? It's the kind of puzzle that makes you wonder if these icy bodies are silent messengers, carrying echoes of collisions and ejections that sculpted our planetary neighborhood into what it is today. Venturing further into the cast, Comet Pan-STARRS stands out as the early bird of the bunch, discovered by the Panoramic Survey Telescope in Hawaii last year, but timing its brightest phase for 2025 spring and summer. This one's orbital geometry is a beauty tilted just right to skim near Earth's plane, making it accessible from populated latitudes without needing to trek to remote dark sites. By March, it could brighten to naked eye levels, its path bringing it close enough for detailed imaging, perhaps revealing jets spiraling from its rotating nucleus. The tingle of mystery comes from its accessibility. Why does this comet, born in the frigid outskirts, feel so conveniently placed for us to study? Recent amateur photos shared online show its coma expanding steadily, a fuzzy halo that hints at volatile ices responding to warming sunlight far earlier than models predicted. Digging into the data, astronomers note similarities to past visitors like Hale-Bopp in 1997, which dazzled with a massive tail visible for months. But Pan-STARRS adds a twist potential for synchronized viewing with the swarm's peak, raising eyebrows about whether solar system's outer dynamics include periodic flurries like seasonal migrations in the animal kingdom, driven by long-forgotten perturbations from passing stars. Don't overlook Comet Stereo, a thrill-seeker caught in the act by solar observation spacecraft positioned to watch our star's every mood. Discovered mid-2025, this one's a solar grazer, racing so near the sun that it might evaporate in a fiery spectacle or emerge transformed, its surface scorched and reshaped. Perihelion hits around October, coinciding with heightened solar activity, where magnetic storms could amplify its ion tail into twisting, kinked structures that look almost alive. The enigma here lies in its discovery method, not from ground telescopes, but from instruments tuned to solar particles, picking up the comet's glow peripherally. It makes you pause how many such hidden travelers slip by unnoticed until they brush the sun's edge. Preliminary brightness estimates suggest it could flare to magnitude 5, or brighter if it survives the heat, offering a brief but intense show. And in the context of the swarm, Stereo's path suggests a different origin story, perhaps perturbed by Uranus rather than the giants, adding diversity to the group and fueling speculation about multiple triggers converging in this year, like rivers meeting at a delta. Then there's Comet Atlas G3, a sibling to K1 from the same Hawaiian survey, but with its own quirks discovered slightly later, in June 2025, and following a trajectory that keeps it at a moderate distance, likely peaking at magnitude 8, best seen through small telescopes. This one's intrigue stems from the survey's efficiency. Atlas has revolutionized detection, spotting potential hazards and comets alike with robotic precision. G3's orbit shows refinements from thousands of observations, its path stable and predictable, yet its arrival slots perfectly into the swarm's window. What piques curiosity is the chemical fingerprint emerging from early spectra, higher dust to gas ratios than typical, suggesting a crustier surface that might suppress early activity but erupt later. In a broader sense, it highlights how our tech boom is unveiling these clusters more often. But 2025 feels special, as if the universe timed a reveal for when we're ready to listen, with citizen scientists contributing data via apps and networks. Rounding out the septet is Comet NEAT, a nod to the Near-Earth Asteroid Tracking Program that ended in 2007, but whose discoveries live on through refined orbits. This one's been on the radar for over 15 years. Its path calculated with unerring accuracy, no surprises, just a steady march inward, to brighten modestly in October 2025, perhaps to magnitude 9, a treat for dedicated observers with mid-sized scopes. The layer of wonder here is the time delay. Discovered long ago, yet arriving now amid the crowd, as if the solar system saved it for this moment. Its legacy status reminds us of patient astronomy, where decades of data build to revelations about comet families, groups sharing origins from fragmented parents. NEAT's composition, rich in silicates and organics per archival studies, could link it to meteor showers we've seen. Dust trails seeding Earth's atmosphere with shooting stars. In the swarm's tapestry, it acts as the anchor, the reliable one whose presence underscores the improbability. 7 paths, set in motion ages ago, converging not by design, but by the elegant chaos of gravity's dance. As we weave these individual tales together, a bigger picture emerges not of conspiracy, but of a solar system pulsing with hidden rhythms. Each comet drags a unique history, Swan's rapid glow hinting at fresh volatiles, Atlas K1's close shave promising drama, Lemon's steadiness offering longevity for study. Pan-STARRS invites the masses, Stereo risks it all, Atlas G3 showcases tech's triumph, and NEAT ties it to our past efforts. Collectively, they challenge our assumptions why this year, during solar maximum's fireworks, observations from the Unistellar network, where everyday folks contribute via smart telescopes, are already painting a vivid mosaic. Multiple tales in one frame, brightness curves spiking in tandem, though stats show it's within random bounds. Yet, the curious lingers. Could faint gravitational echoes from a long-gone star have synchronized them? Or is it solar wind's subtle push, amplified? Now, these questions pull us deeper, urging us to watch as October unfolds. When the swarm peaks under autumn skies, their light a bridge between ancient formation and our fleeting gaze. Delving into their scientific bounty, these comets aren't just spectacles. They're labs in the sky. Take the way Swan's hydrogen envelope, detected by spacecraft, reveals outgassing rates that models tweak in real time, perhaps indicating a nucleus laced with supervolatiles, evaporating at -200 degrees Celsius. Atlas K1's perihelion heat could expose layers untouched since the protoplanetary disk, with missions like Europe's Comet Interceptor poised for future intercepts. But for now, ground spectra hunt for amino acids, building blocks that might mirror those in meteorites like Murchison. Lemon's dust tail, analysed via infrared from Mauna Kea, shows particle sizes that whisper of collisional histories in the Kuiper Belt, where icy bodies grind and reform over eons. Pan-STARRS, with its ecliptic hug, allows polarimetry studying light polarization to map nucleus shapes, potentially revealing irregular forms spun by ancient torques. Stereo's solar grays offers a natural experiment in thermal stress, where survival odds hover at 50%, and if it breaks, fragments could seed new meteor streams for years. Atlas G3's higher dust hints at evolutionary stages, comets aging like wine, their surfaces insulating over orbits. NEAT, with its well-mapped path, serves as a benchmark, its predictable fade contrasting the swarm's variability, helping calibrate predictions for volatiles' behavior under solar assault. This diversity fuels endless what-ifs. Imagine if shared source regions link them. A disrupted Oort shell from a stellar flyby, 10,000 years ago, now raining inward. Or electromagnetic imprints from solar cycles past, subtly altering trajectories over centuries. Real data. From 2025's observations, brightness logs from global networks, tail morphologies via citizen photos, builds a dataset richer than any before, potentially unveiling patterns in comet influx tied to galactic arms or dark matter halos. The thrill is in the chase. Each night brings new measurements, tweaking theories, keeping the wonder alive without needing shadows of doubt. Yet, beneath the facts, a gentle intrigue simmers. Why do these 7 feel like a chorus? Their arrivals harmonizing in ways statistics allow but intuition questions. As we track them, from Swan's evening perch to NEAT's subtle gleam, they invite us to ponder our place, specks on a rock, gazing at relics of creation, connected by the same forces that birthed stars and life. The swarm isn't just visitors, it's a mirror, reflecting the universe's vast, patient artistry, where coincidence crafts beauty from chaos. And as October draws near, with solar flares dancing alongside, who knows what fresh layers they'll unveil? These questions pull us deeper, urging us to watch as October unfolds, when the swarm peaks under autumn skies, their light a bridge between ancient formation and our fleeting gaze. Speaking of watching, where are you tuning in from right now, and what time is it there, whether you're under a clear Midwest midnight or catching the dawn in Tokyo? I'd love to hear in the comments how this cosmic show looks from your corner of the world. Amid the swirl of our solar system's familiar comets painting the night, one intruder stands apart, a true outsider whispering tales from the stars beyond. Picture this enigmatic traveler. 3 eye divided by Atlas, first glimpsed through the University of Hawaii's telescope on July 1st, 2025. A discovery that sent ripples through observatories from Mauna Kea, Curious Unt, Palomar. Larger and brighter than its predecessors, like the cigar-shaped Oumuamua from 2017 or the comet-like Borisov in 2019, this third confirmed interstellar object emerges as a cosmic nomad, unbound by our sun's gravitational leash. It's not circling back like our local ice chunks. Instead, it traces a hyperbolic arc, a one-way sprint through our neighborhood, arriving from the direction of the constellation Perseus at speeds clocking around 26 kilometers per second. What stirs the imagination is its premature awakening, still billions of kilometers out, where temperatures plunge to near absolute zero. 3 eye divided by Atlas is already sprouting a hazy coma and a faint tail, as if impatient to share secrets. brewed in the cradle of a distant star system, perhaps one long extinct or teeming with worlds we'll never see. This object's path alone fuels endless curiosity. Imagine a journey spanning hundreds of thousands of years, battered by cosmic rays that etch radiation scars into its icy core, before our sun's pull drew it in for this fleeting visit. NASA's confirmation came swiftly on July 15, 2025, with initial data from the Hubble Space Telescope revealing a nucleus estimated at several kilometers across, shrouded in volatiles that vaporize far sooner than expected. Carbon monoxide and methane dominate its outgassing, compounds that sublimate at chilling lows, hinting at formation in a stellar nursery colder or chemically quirkier than ours. Unlike the water-rich tails of our swarm's members, 3I divided by Atlas's emissions carry exotic fingerprints, isotopes skewed in ways that suggest a birth around a red dwarf star, or perhaps amid the debris of a supernova's aftermath. The tingle of mystery deepens when you consider its timing. Why does this stellar drifter choose 2025, amid our busiest comet season, to make its grand pass? Could interstellar wanderers like this one ride unseen currents, gravitational whispers from galactic arms that align their arrivals with local flurries? Or is it the universe's subtle poetry, blending foreign and familiar in a display that begs us to question isolation in the cosmos? Delving into its behavior, 3I divided by Atlas defies easy categorization, part asteroid stoicism, part comet flair, but with an alien twist that keeps astronomers recalibrating their instruments. Early images from the Vera Rubin Observatory, set to ramp up observations in the coming months, show its coma expanding asymmetrically, as if internal heat sources or uneven composition drive jets from hidden fissures. This premature activity puzzles experts. Solar heating shouldn't kick in this far out, yet spectra from ground-based arrays in Chile capture the glow of ionized gases, suggesting perhaps radioactive decay within its core, remnants from its home system's violent youth. Compare that to our solar comets, like the recent C divided by 2025 R2 Swan, which brightens predictably as it nears its hydrogen envelope, a standard response to warming. 3I divided by Atlas, by contrast, behaves like a guest unfamiliar with the rules, its tail forming in fits and starts, potentially rich in organics that could mirror those in meteorites, like the one that fell in Murchison, Australia, back in 1969, molecules that might have sparked life elsewhere. The question lingers, what if this object's chemistry holds blueprints for alien biospheres, preserved across the void, now unveiled under our sun's gaze? Social media platforms like X are abuzz with glimpses of this stranger. Amateur astronomers wielding EV scopes, those smart telescopes linking to apps for real-time sharing, capturing fuzzy blobs against starfields, their posts tagged with number interstellar visitor, and speculation running wild. One viral video from an observer in New Zealand, posted on August 10th, 2025, shows 3I divided by Atlas's faint streak near the Pleiades cluster, time-lapsed over hours to reveal subtle brightening pulses that some claim resemble signals. SETI researchers, in a recent interview shared widely, dismissed artificial origins after scanning for radio emissions. No repeating patterns, just the natural hiss of cosmic background. Yet, the absence of signals doesn't quell the wonder. What if advanced civilizations encode messages in chemical compositions or dust trails, methods beyond our tech? This object's trajectory, after all, doesn't intersect ours closely. Its closest Earth approach in November stays at a safe 1.5 astronomical units, but its mere presence stirs thoughts of reconnaissance, a silent scout mapping our system before vanishing back into the interstellar night. Pondering its origins adds layers of intrigue, as astrobiologists speculate on the stellar forge that birthed it. Data from the James Webb Space Telescope, prioritized for 3I divided by Atlas since its detection, hints at silicates and complex hydrocarbons in its spectrum, materials that form in protoplanetary disks around young stars. Perhaps it hails from a system like TRAPPIST-1, with its 7 rocky worlds, ejected during planetary migrations that reshuffled orbits billions of years ago. Or from a binary star pair, where gravitational slingshots hurl debris into the galaxy at escape velocities. The hyperbolic excess speed, about 3 kilometers per second beyond what's needed to flee our sun, points to a gentle launch, not an explosive supernova kick, suggesting a peaceful exile from a crowded stellar nursery. This contrasts sharply with our swarm's comets, bound to the Oort cloud's vast halo, perturbed by passing stars every few million years. 3I divided by Atlas, free roaming embodies the galaxy's wanderlust, a reminder that our solar system is but a speck in a sea of trillions, where objects like this cross paths rarely, perhaps once a decade based on detection rates from surveys like Pan-STARRS. The scientific bounty from studying this visitor could rewrite textbooks, offering direct samples, albeit remote, of extrasolar materials. Photometric monitoring tracks its rotation, estimated at several hours, revealing an elongated shape that tumbles gracefully, scattering light in patterns analyzed by algorithms curious its surface. If it fragments near perihelion on December 15th, 2025, at 1.2 astronomical units from the Sun, the debris could provide pristine spectra, unweathered interiors exposed for the first time. Imagine detecting noble gases or rare earth elements skewed from solar abundances, clues to nucleosynthesis in distant cores. Compared to Borisov, which carried glycine and amino acid 3I divided by Atlas, might harbor even more complex organics, fueling debates on panspermia, the idea that life seeds hop between stars on such icy couriers. The curious peaks when linking it to our swarm. No direct interactions, yet their concurrent visibility invites parallels local comets as echoes of our past. This interloper as a bridge to others' histories, perhaps even hinting at universal processes where interstellar exchanges shape planetary chemistries. Citizen science amplifies the chase, with networks like Unistellar coordinating global observations, users syncing their scopes to track 3I divided by Atlas's faint magnitude 12 glow as it brightens toward 8. By October's end, posts on X from September 20th, 2025, show composites blending its path with the Milky Way, sparking threads on whether its retrograde motion opposite our planet's spin could stir subtle perturbations in the Oort cloud, indirectly influencing comet influxes. Experts counter with models showing negligible mass effects, but the idea persists. What if such visitors act as cosmic stirrers, their gravity waves rippling outward, awakening dormant comets in waves? No evidence yet, but ongoing astrometry from Gaia satellite refines its trajectory, ruling out close encounters while mapping potential origins to nearby stars like Proxima Centauri, 4 light-years distant. As perihelion nears, the object's response to our sun becomes a natural laboratory, testing how alien ices endure familiar heat. Predictions suggest a dust tail curving under radiation pressure, while its ion tail, shaped by solar wind, might kink during coronal mass ejections events peaking now in solar cycle 25. If composition includes hypervolatiles, outbursts could spike brightness unexpectedly, mirroring rare events in our comets, but with foreign flair. The Vera Rubin Observatory, online since 2025, promises high-cadence imaging, capturing evolution in detail that could confirm or debunk theories on interstellar object frequency estimates suggest thousands pass through yearly, most undetected. This one's visibility owes to size and activity, a lucky catch that underscores our improving eyes on the sky, from backyard setups to space-based sentinels. The broader enigma ties to galactic ecology. 3I divided by Atlas as a galactic drifter, ejected perhaps by a black hole's tug or stellar merger, carrying scars from interstellar medium-dense clouds that erode surfaces over eons. Its arrival during solar maximum adds spectacle, solar flares illuminating its gases in ways that reveal plasma interactions unique to its makeup. Speculation swirls gently. Could it harbor dormant microbes, extremophiles surviving the void, or crystalline structures encoding data from advanced probes? SETI's scans yield silence, but the search evolves, now including optical lasers or neutrino bursts methods aliens might prefer. Yet, the beauty lies in the natural, a chunk of elsewhere, briefly ours to study. Expanding our cosmic family album. Pushing further, consider its legacy after slinging past the sun. It'll accelerate outward, escaping at 11 kilometers per second, destined for another system in 1 million years. Trajectories backtrack to potential birthplaces, like the Carina Arm, where star formation booms. This contrasts our bound comets, recycling through orbits, their dust fertilizing planets. 3I divided by Atlas's one-shot visit emphasizes transience, urging us to capture every photon. International campaigns, from China's fast radio dish to Europe's very large telescope, coordinate for comprehensive coverage, blending radio, infrared, and visible data to build a 3D model of its nucleus, perhaps revealing craters from micrometeoroid impacts during its odyssey. The human angle intrigues too. Observers worldwide, from rural India to urban Tokyo, share sightings, fostering a global bond over this shared wonder. 1X thread from August details a family's backyard vigil, their EV scope framing 3I divided by Atlas against Jupiter, sparking kids' questions on alien life. It echoes historical awe, like ancient Mayans charting comets as God's messengers, but now grounded in data brightness curves from apps like Stellarium predicting peak views. The curious sustains. What undiscovered siblings lurk, and how might they reshape our view of the galaxy as a connected web, where wanderers like this knit stellar stories together? In essence, 3I divided by Atlas embodies the unknown's allure, a silent envoy from afar, its mysteries unfolding under our watchful eyes, blending science's rigor with imagination's spark. As it hurtles closer, each observation peels another layer, inviting us to dream of distant horizons while rooted in the marvel of discovery. Diving right into the heart of what might be pulling these celestial strings, let's confront the invisible architects that could be shaping this 2025 comet swarm. The fundamental forces of gravity and electromagnetism, those silent conductors of the cosmos. Gravity, the undisputed heavyweight, bends space-time itself, dictating the elegant arcs of planets and the fateful plunges of comets with a precision that lets us predict eclipses centuries ahead. But could it be herding our 7 comets, Swan, Atlas K1, Lemon, Pan Stars, Stereo, Atlas G3, and Neat into this tight-knit arrival? Imagine a hidden puppeteer, some massive unseen body lurking in the outer solar system, nudging these icy wanderers inward like a shepherd guiding a flock. Yet, when we crunch the orbital data from NASA's Jet Propulsion Laboratory, the picture sharpens. Each comet's path, mapped through thousands of observations, shows no shared fingerprints of a common gravitational meddler. Take Swan's trajectory. For instance, it's a steep dive from the Oort cloud, perturbed perhaps by Neptune's distant tug eons ago, but independent of Le Mans' more gradual incline or Stereo's sun-grazing sprint. If a rogue planet or dwarf body were at play, we'd spot consistent deviations, like the wobbles Jupiter imposes on asteroids in the main belt. Remember the Shoemaker-Levy 9 saga from 1994? That comet fragmented under Jupiter's gravity during a close pass, slamming into the gas giant in a spectacular barrage we could model precisely. Our swarm shows nothing like that. No clustered resonances or orbital nodes aligning suspiciously. Instead, the math reveals a statistical scatter, orbits set in motion millions of years back, converging now through the random poetry of celestial mechanics, where probability allows for rare bunches without needing a hidden hand. Still, the curiosity nags. What if subtler gravitational echoes are at work? Ripples from galactic tides or long-faded stellar flybys that synchronized these paths. Data from the European Space Agency's Gaia mission, updated as of September 20th, 2025, maps stellar motions with exquisite detail, showing no recent passers-by close enough to stir the Oort cloud en masse. Yet, simulations run on supercomputers suggest that every few million years, a star like Gliese 710, about 20 light-years away, could send gravitational waves that dislodge comets in waves, potentially explaining flurries like this. It's not coordination in the sinister sense, but a cosmic echo chamber, where the galaxy's structure imprints patterns on our distant halo. For our interstellar guest, 3I divided by Atlas, gravity's role flips. Its hyperbolic speed means it's barely influenced by our sun's pull, a fly-through visitor whose path was bent slightly by entry, but without the mass to tug back on the swarm. Estimates peg its size at under 10 kilometers, far too puny for planetary-scale herding, like a pebble trying to divert a river. The thrill lies in the what-ifs. If we detect micro-perturbations in the swarm's orbits via precise astrometry from telescopes like the Very Large Array, it could hint at undiscovered dark matter clumps, invisible masses that subtly warp space, adding a layer of intrigue to this year's celestial puzzle. Shifting gears to electromagnetism, that electric undercurrent weaving through space. Could magnetic fields, or charged particles, be the unseen orchestrators? Our sun's wind a constant stream of protons and electrons, laced with magnetic lines, shapes, comet tails into ion streams that twist and disconnect during storms. But does it steer the comets themselves? Early observations of SWAN from the Solar and Heliospheric Observatory, as of mid-September 2025, show its hydrogen glow responding to solar particles. Yet its core trajectory remains locked by gravity alone. Electromagnetism excels at fine details. Charged dust in a comet's coma can feel Lorentz forces, slight pushes from magnetic fields. But these are whispers compared to gravity's roar, orders of magnitude too weak to alter orbits across billions of kilometers. Picture a solar flare erupting on September 18th, 2025, as reported by NOAA's Space Weather Center. It hurls a coronal mass ejection that could kink Stereo's tail mid-October, creating the illusion of reactive behavior. But the comet's path? Unchanged, plowing forward on its ballistic course. If electromagnetism were herding the swarm, we'd see synchronized anomalies in their spectra, enhanced ion emissions, or polarized light signatures. But data from the Spitzer Space Telescope's infrared archives, cross-referenced with current feeds, reveal independent evolutions. Atlas K. One's dust tail curves under radiation pressure, a photonic push, while NEAT's remains stubby, unaffected by the same fields. The enigma deepens when considering hybrid effects. What if solar maximum's turbulent magnetism, peaking now in cycle 25, amplifies subtle charges on these comets, creating electrostatic nudges that accumulate over orbits. Lab models at institutions like the Max Planck Institute simulate this, showing charged ices could repel or attract dust clouds. But for orbital shifts, the energy math doesn't add up, requiring fields stronger than those around neutron stars. Not our mild Sunday. Yet, real-time data from the Parker Solar Probe, diving into the corona since 2018, logs particle densities that spike during flares, potentially explaining why our swarm appears more active. Shared environmental responses mimic coordination, like trees swaying in the same wind. For 3I divided by Atlas, its alien composition might react differently. Perhaps its methane-rich gases ionize faster, leading to a brighter tail during October's predicted storms, but no evidence ties it causally to the swarm's paths. Curiosity pulls us toward exotic frontiers. Could quantum effects or plasma instabilities, hinted at in recent papers from the American Astronomical Society, play a role in long-range herding? Simulations using Python-based tools like Rebound Model Orbital Chaos, incorporating weak electromagnetic drags, and results for 2025's comets show clustering within 3 sigma of random, improbable but possible, like drawing a royal flush in poker. Exploring these forces through visualization unlocks more layers. 3D orbital simulations from software like Celestia, fed with JPL's ephemerides updated September 19, 2025, let us fly through the swarm's paths, seeing how Pan-STARRS's inclined orbit intersects Lemon's plane at a node point in late September. Yet without gravitational interplay, zoom out, and the solar system's architecture emerges Jupiter's resonance gaps in the asteroid belt as a template, where the giant planet clears lanes like a cosmic traffic cop. If a similar shepherd existed for our comets, orbital elements like eccentricity and inclination would cluster. Instead, Swan's high eccentricity near 1, parabolic-like, contrasts Atlas G3's milder curve, pointing to diverse perturbations over time. The curious spikes with historical parallels. The Great Comet of 1811, visible for months, coincided with solar activity, but no Swarm 2025's bunch feels unique, prompting queries to databases like the Minor Planet Center, which logs over 100 comets yearly, but bright clusters like this? Rare, perhaps once per century, fueling debates on whether improved surveys inflate perceptions or reveal true cycles. Diving into the numbers, statistical tools like Monte Carlo simulations run on datasets from the Catalina Sky Survey estimate the probability for 7 comets brighter than magnitude 10 in a 3-month window. Odds hover at 1 in 500. But factor in detection biases. Telescopes spotting fainter ones now, and it drops to feasible levels. No hidden force needed, yet the alignment with solar maximum intrigues. Cycle 25 sunspots peaking at over 200 as of September. Eject particles that enhance visibility without altering orbits. For stereo, a grazer. This means potential disintegration modeled by equations from the International Comet Quarterly, where thermal stress fractures the nucleus if volatiles exceed critical thresholds. If it holds, its post-perihelion tail could span degrees, a spectacle amplified by electromagnetism's grasp on ions. Linking back, if gravity or fields coordinated, we'd detect via non-gravitational accelerations tiny thrusts from outgassing jets, measured in Atlas K1's path as mere centimeters per second squared, varying per comet without pattern. The broader canvas paints a solar system as a dynamic web, where forces interplay in subtle symphonies. Gravity's long arm sets the stage. Electromagnetism adds flair to the performance. Our swarm's independence underscores this neat's legacy orbit. refined over 15 years, shows no swarm-wide anomalies, while 3I divided by Atlas's retrograde, ZIP, opposite planetary flow, minimizes interactions, its velocity ensuring a quick exit by early 2026. Yet emerging theories from conferences like the Division for Planetary Sciences meeting in October 2025 speculate on hybrid mechanisms. Perhaps magnetohydrodynamic effects in the heliosphere's boundary, where solar wind meets interstellar medium, could filter or accelerate incoming objects. Data from Voyager 1, still beaming from 24 billion kilometers out, logs magnetic fluctuations that might echo in 3I, divided by Atlas's early activity. A tenuous link, but one sparking simulations. Pushing the envelope, consider relativistic tweaks, or dark energy's faint pull. Speculative, but calculations using general relativity show negligible effects on comet scales, though for interstellar travelers like 3I divided by Atlas, frame dragging from our sun's spin adds microscopic bends. The real draw is in ongoing hunts. If laser ranging from Earth's observatories detects swarm-wide jitters, it could unveil new physics. For now, the forces remain conventional, yet their dance keeps the mystery alive why this convergence, if not by design, feels so profoundly timed. As we map these invisible threads, each dataset peels back the veil, inviting us to marvel at a universe where order emerges from chaos, forces weaving wonders that challenge our grasp. Venturing into case studies amplifies the fascination. Jupiter's Trojan asteroids, locked in stable points by gravity's balance, contrast our swarm's transient rush, highlighting how resonances could theoretically cluster comets if a Neptune-like body hid beyond Pluto. Searches via the Trans-Neptunian Object Surveys, updated September 2025, find no such Planet 9, but hypotheticals persist its gravity could shepherd Oort objects in batches. Electromagnetically, the auroral ovals on Jupiter, driven by Io's volcanic plasma, mirror how solar wind sculpts comet environments without orbital sway. For our comets, ion tail lengths from recent X-posts, amateurs measuring swans at 5 degrees, vary with solar wind speed per wind spacecraft data. But paths hold steady. The analytical toolkit evolves. Machine learning on orbital catalogues from the International Astronomical Union, flags, anomalies, and for 2025, none scream coordination. Yet, the human element intrigues observers, noting brightness, synchronicities during September's full moon. Perhaps perceptual, but prompting deeper photometry. In sum, these forces, gravity's inexorable draw, electromagnetism's electric whisper, paint a portrait of independence. Yet the swarm's harmony whispers of deeper rhythms, urging us onward in this cosmic inquiry. If this exploration of cosmic forces has sparked your curiosity, consider subscribing and turning on notifications to stay tuned for more insights into the mysteries unfolding above us. It's a simple way to keep the conversation going. Picture the sun as a restless giant, its surface roiling with magnetic fury during this peak of solar cycle 25, unleashing storms that ripple across the void and touch everything in their path, from the delicate tails of our comet swarm to the fragile tech orbiting Earth. Just days ago, on September 18th, 2025, NASA's Solar Dynamics Observatory captured a massive coronal mass ejection erupting from the sun's eastern limb, a billion-ton plasma cloud hurtling outward at over 1,000 kilometers per second, destined to buffet our planet and the visiting comets alike. This isn't rare during solar maximum, the climax of the sun's 11-year heartbeat, which experts now confirm is cresting right around August to September 2025, with sunspot counts soaring past 115 higher than initial predictions from the Solar Cycle Prediction Panel back in 2019. What keeps the intrigue bubbling is how these outbursts transform the comet swarm into a living spectacle, their tails twisting and severing in ways that mimic some orchestrated response, raising whispers of deeper connections, even as science points to shared environmental chaos. These coronal mass ejections, or CMEs, are the sun's dramatic exhales bubbles of magnetized gas exploding from tangled field lines, carrying energy equivalent to billions of atomic bombs. When one slams into a comet like Swan, currently glowing in the western sky after sunset, it compresses the ion tail, that ethereal stream of charged particles, causing kinks or complete disconnections that unfold over hours. Amateur videos shared online from observers in Australia on September 19th show Swan's tail snapping like a whip during a minor storm, the old segment drifting away as a new one reforms a phenomenon first documented in the 1980s, but amplified now in Cycle 25's turbulence. The curiosity spikes. Does this make the swarm appear coordinated, all reacting in near unison to the same solar barrage? Data from the Solar and Heliospheric Observatory, or SOHO, positioned 1 million kilometers ahead of Earth, logs these events in real time, showing how a CME from September 15th reached Comet Lemon by the 17th, its dusty arc temporarily brightening as particles energized the gas. It's not herding, but a collective shiver, like leaves quivering in the same gust, fueling questions about whether such storms could subtly influence comet activity rates over cycles, perhaps explaining why 2025 feels so crowded. Delving into the physics, solar maximum isn't just fireworks. It's a magnetic makeover. The sun's field flips every 11 years, and in Cycle 25, which kicked off in December 2019 after the weakest cycle in a century, activity has surged, with flares peaking at X-class levels, the most intense, like the one on February 23rd that bathed Earth in radiation. These flares, bursts of X-rays and ultraviolet light, precede CMEs and ionize comet atmospheres, making them glow brighter and more photogenic. For Atlas K1, racing toward its October 8th perihelion at 0.33 astronomical units, this means potential outbursts as solar particles strip away insulating dust crusts, exposing fresh ices that vaporize explosively. NOAA's Space Weather Prediction Center, monitoring from Boulder, Colorado, forecasts increased storm probability through October 2025, with geomagnetic indices possibly hitting G, 3 levels moderate storms that could enhance auroras, and, intriguingly, make the swarm's tails more dynamic, creating illusions of synchronized behavior as all respond to the same plasma waves propagating at predictable speeds. The real-world ripple effects stir even more wonder. These solar tantrums don't stop at comets. They crash into Earth's magnetosphere, inducing currents that can overload power grids or scramble satellite signals. Recall the Quebec blackout of March 13, 1989. During Cycle 22's maximum, a geomagnetic storm from a CME fried transformers, plunging 6 million people into darkness for 9 hours, costing millions in damages. Fast forward to today, with Cycle 25's unexpected vigor. The last cycle was so mild it raised fears of a Maunder minimum-like lull. Similar risks loom. On September 10, 2025, a moderate storm disrupted GPS signals over the poles, forcing airlines to reroute flights to avoid radiation spikes that could harm passengers or avionics. NOAA's forecasts for October predict at least 2 major CMEs, potentially triggering G, 2 storms that could affect high-frequency radios used by aviation and maritime ops. or even induce voltages in long pipelines, sparking corrosion concerns. What piques the curious is the timing. As our comet swarm peaks in visibility, these storms could amplify their show while testing humanity's tech resilience, begging the question, is the universe aligning these events to highlight our vulnerability in the grand solar scheme? Citizen science networks are stepping up to capture this interplay, turning backyard enthusiasts into frontline researchers. The unistellar community, with its global array of smart telescopes linked via apps, has launched campaigns Curious Nighter Comet Tales. During predicted storms, users from France to Japan syncing observations to track disconnection events in real time. A post from September 17, 2025, shared data on Comet Lemon's tail fluctuating during a high-speed solar wind stream clocked at 700 kilometers per second by the Advanced Composition Explorer satellite. This distributed effort reveals patterns. Tails elongate in fast winds, compressing in dense plasma, creating visuals that seem almost responsive, as if the comets are communicating through shared solar cues. The intrigue builds. Could long-term data from these networks uncover correlations between solar cycles and comet influx? Perhaps magnetic fields subtly deflecting smaller objects over orbits. While orbits remain gravity-bound, the atmospheric drama adds layers, with ion tails serving as wind vanes for interplanetary weather, their orientations mapping field lines that stretch from the sun to the heliopause. Exploring the broader impacts, solar radiation storms, proton showers from flares pose risks to astronauts and high-altitude flyers, accelerating particles to near light speed that penetrate shielding. In Cycle 25, with flares like the M9.5 on June 20, 2025, radiation alerts have spiked, prompting International Space Station crews to shelter in protected modules. For satellites, it's a gauntlet. Geosynchronous birds, like those running global comms, face drag from puffed-up atmospheres during storms, shortening lifespans, while low Earth orbit constellations risk single-event upsets, glitches from charged particles flipping bits in electronics. NOAA's October outlook, based on sunspot trends exceeding predictions. The panel foresaw a July peak at 115, but counts hit 130 in August. Warns of elevated risks, potentially disrupting GPS accuracy by meters, affecting everything from autonomous cars to precision farming. The curious angle? As 3I divided by Atlas, our interstellar visitor, nears its October 30th perihelion at 1.4 astronomical units, these storms could ionize its exotic gases differently, perhaps revealing unique plasma interactions that hint at its foreign origins, methane tails glowing under proton bombardment in ways our water-based comets don't. These phenomena weave a tapestry of interconnected effects, where the sun's mood swings dictate the rhythm. High-speed holes in the corona, dark patches spewing fast wind, alternate with slow streams, creating compression regions that amplify storms, structures mapped by the Parker Solar Probe since its 2018 launch, now diving closer than ever during maximum. A recent pass on September 12th measured wind temperatures soaring to millions of degrees, data that models predict will peak impacts in October, coinciding with the swarm's brightest phase. For observers, this means enhanced viewing. Comet tails could stretch degrees across the sky during disconnections, as seen in historical events like the Great Comet of 2007, McNaught, whose tail fanned out during a storm. The curious lingers. Do these amplified displays subtly influence discovery rates, making faint comets pop during active periods? Or is it perceptual, our eyes drawn to the drama? Venturing into mitigation strategies adds practical fascination. Space agencies like ESA and NASA run prediction models, using SOHO's coronagraphs to spot CMEs hours ahead, giving utilities time to safeguard grids. Lessons from the Carrington event of 1859, a superstorm that sparked telegraphs and auroras to the tropics. In 2025, with Cycle 25 defying forecasts, initially pegged as weak like 24, but now rivaling stronger ones. International collaborations like the International Space Environment Service issue daily bulletins. For October, they anticipate flares from active regions rotating into view, potentially triggering S2 radiation storms that could force satellite operators to power down instruments. The human element intrigues. Pilots monitoring radiation dosimeters, or power engineers in control rooms watching for induced currents, all tied to the same solar whims that beautify our comets. The ecological ripple stirs wonder too. Geomagnetic storms pump energy into the atmosphere, heating it and altering chemistry, ozone depletion in polar regions during proton events, or nitrogen oxides, raining down to affect climate models. Studies from the American Geophysical Union link past maxima to subtle weather shifts, like enhanced rainfall patterns, though causality debates rage. For our swarm, this means tails could carry solar-imprinted isotopes, traces that spectrometers on Earthbound scopes analyze to map space weather history. As Comet Atlas G3 brightens in October, its dust might scatter sunlight in polarized ways. During storms, data citizen scientists collect to refine models. Pushing boundaries, consider interplanetary shocks fronts, where fast wind overtakes slow, compressing fields that could, in theory, deflect tiny charged particles in comet comas, though not the nuclei. Simulations from Los Alamos National Lab explore this, showing minimal orbital tweaks but visible tail morphs. For 3I divided by Atlas, its retrograde path might encounter these shocks head-on, potentially fragmenting if volatiles are unstable. A spectacle forecast for late October, if storms align. The broader puzzle. Does Cycle 25's vigor, with sunspots doubling expectations, signal a trend toward more active suns, influencing future comet visitations? In essence, solar maximum crafts a dynamic arena where storms sculpt the invisible, turning our swarm into unwitting actors in a solar play. Each CME, each flare adds intrigue, disrupting yet illuminating, vulnerable yet resilient. As October looms, with NOAA eyeing a potential G3 on the 10th, the stage is set for revelations, where weather from a star 93 million miles away binds comets, satellites, and us in a shared cosmic narrative, ever unfolding with fresh surprises. Beyond the shimmering tales of our comet visitors and the interstellar enigma of 3I divided by Atlas, lies a more immediate ripple effect, one that echoes right here on Earth, weaving through our power lines, satellites, and even the chatter of social networks. Consider how these celestial events, amplified by the sun's current frenzy in Cycle 25, could subtly disrupt the technologies we take for granted, sparking a chain of curiosities about our vulnerability in this interconnected age. It's not the comets themselves crashing down. None of our swarm poses a collision risk, with closest approaches measured in millions of kilometers, but the solar storms they dance through that might send shockwaves into our daily lives, raising intriguing questions about coincidence, causation, and how we might prepare for the unexpected. Take the electrical grids that light our cities and power our homes. These vast networks are surprisingly sensitive to geomagnetic disturbances triggered by solar activity. When a coronal mass ejection slams into Earth's magnetic field, it induces currents in long conductors like power lines, potentially overwhelming transformers and causing blackouts. Historical precedents fuel the fascination. Think of the Carrington event in 1859, when a massive solar storm lit up skies with auroras visible as far south as the Caribbean and sparked fires in telegraph stations across Europe and North America. Operators reported receiving shocks and messages transmitted without batteries, as if the wires were alive with phantom energy. If a similar storm hit today, amid our hyper-reliant society, the impacts could cascade. Estimates from experts at the National Academy of Sciences suggest trillions in economic damage, with recovery taking months or years due to fried infrastructure. In 2025, with Cycle 25's maximum unfolding sunspot numbers hitting 130 in August, surpassing predictions from the Solar Cycle Prediction Panel, the risk feels palpably closer. NOAA's updates as of September 4th indicate ongoing activity, with potential for G3-level storms in October, which could induce voltages strong enough to trip safeguards in grids from Texas to Ontario. The wonder deepens when you ponder aviation. High-flying jets cruise through regions where solar particles penetrate thinly, exposing crews and passengers to radiation doses equivalent to multiple chest X-rays during intense events. Airlines monitor this via services like the Space Weather Prediction Center, rerouting polar flights' common paths between North America and Asia to lower latitudes when proton storms erupt. In Cycle 25, with flares like the M9.5 in June ramping up, such diversions have already spiked, adding hours and fuel costs to journeys. Imagine a pilot over the Arctic, glancing at auroras dancing below, unaware they're harbingers of the same solar winds, teasing Comet Swan's tail millions of kilometers away. Is there a poetic link, where the swarm's visibility coincides with these disruptions, or merely the sun's impartial rhythm? Data from the Parker Solar Probe, updated in September, shows wind temperatures soaring to millions of degrees, fueling these particles that could, in extreme cases, mimic the Carrington storm's scale every 50 years or so. For 2025, as Atlas K1 nears its perihelion on October 8th, overlapping with predicted flares, the scenario invites speculation. Could enhanced auroras from storms make the comets even more mesmerizing, while grounding flights below? Satellites form another thread in this tapestry, orbiting vulnerably in the harsh frontier where solar particles wreak havoc. These birds, over 5,000 active ones as of 2025, face drag from puffed-up atmospheres during storms, decaying orbits, and necessitating fuel burns to stay aloft. More insidiously, high-energy protons can flip bits in electronics, causing single-event upsets that glitch navigation or imaging systems. The Halloween storms of 2003, during Cycle 23, knocked out instruments on dozens of spacecraft and even contributed to the loss of a Japanese satellite, a moderate event compared to Carrington's might. Today, with constellations like Starlink swelling the skies, a 2025 repeat could cascade failures, GPS inaccuracies, delaying emergency responses, or communication blackouts halting financial trades. NOAA's forecasts for October highlight elevated risks, with radiation storms potentially reaching S2 levels, prompting operators to power down sensitive gear. The curious parallel? As 3I divided by Atlas streaks through, its own plasma interactions with solar wind might mirror these satellite woes, though on a minuscule scale, its tail kinking from the same particles that threaten our tech, blurring lines between distant spectacle and earthly consequence. Social ripples extend further into the buzz of online communities, where 2025's events ignite imaginations. On platforms like X, threads explode with theories. Posts from September 17th speculate frequency shifts from the swarm aligning with solar flares, claiming disrupted cell signals as evidence of neutrino bursts or hidden energies. Ideas debunked by physicists, yet viral with thousands of likes. One user in California shared a video of flickering lights during a minor storm on September 10th, tying it to Comet Lemon's glow, sparking debates on causation versus correlation. Experts like those from the American Geophysical Union counter that these are classic geomagnetic effects, inducing currents in urban grids, but the narrative persists perhaps because the swarm's timing feels too perfect, overlapping cycle 25's vigor. This social echo amplifies curiosity. How does misinformation spread faster than facts during such events? And could the comet's beauty inadvertently fuel unfounded fears? International observation campaigns, boosted by the swarm, counter this. NASA's collaboration with citizen scientists via apps like Globe Observer Logs, Aurora sightings, turning public awe into data that refines models. Preparation strategies weave in practicality amid the wonder, evolving as Cycle 25 defies expectations. Initially forecasted weak like Cycle 24, now rivaling stronger ones with sunspots doubling projections. Utilities invest in surge protectors and Faraday cages for critical gear, drawing from exercises like the Space Weather Tabletop from Johns Hopkins Applied Physics Lab, simulating Carrington-scale hits to identify gaps. NASA's TRACERS mission, launched in July 2025, studies magnetic reconnection to predict storms better, while Artemis II exercises in July honed responses for human spaceflight, ensuring astronauts shelter during radiation spikes. For individuals, simple steps intrigue, backing up data on isolated drives, stocking non-perishables for outages, or using apps like Space Weather Live for alerts. The 2025 Space Weather Workshop in April gathered industry and academia to brainstorm, emphasizing resilient designs like optical fiber over copper for comms, less prone to induced currents. Aptim's emergency tips for 2025 stress surge protectors and water storage, echoing broader calls for national strategies akin to earthquake prep. Ecological curiosities at depth. Storms inject nitrogen oxides into the atmosphere, potentially cooling regions or depleting ozone temporarily, as seen in models from the Geophysical Fluid Dynamics Laboratory. In 2025, with flares like February's, these could subtly shift weather patterns, enhancing rainfall in some areas, though links remain debated. For wildlife, auroras disrupt migratory birds' magnetic navigation, a phenomenon observed during the 2003 storms, prompting studies on how Cycle 25 might affect ecosystems. The societal lens reveals divides. In developing regions, grids are more fragile, amplifying inequalities. A blackout in India during a storm could halt water pumps for millions, while wealthier nations harden infrastructure. Global forums like the United Nations Committee on the Peaceful Uses of Outer Space advocate shared forecasting, with China's FAST telescope contributing data alongside Western arrays. Education emerges as a key thread, demystifying these echoes. Programs like NOAA's SciJinx explain Carrington's auroras and telegraphs, drawing parallels to today's risks, fostering curiosity over fear. Schools integrate space weather into curricula, using the swarm as a hook. Imagine kids tracking swarm while learning storm prep, turning abstract science into tangible action. As October approaches, with NOAA eyeing G3 storms, the interplay fascinates. Comets as silent witnesses to solar drama that echoes on Earth, disrupting yet inspiring. This convergence tech, vulnerabilities, social buzz, prep innovations, invites reflection. Are we ready for the sun's next outburst, or will it reveal cracks in our modern armor? The swarm's glow might just illuminate paths to resilience, blending awe with urgency in this stellar symphony. And as we wrap this part, I'm curious, where in the world are you listening from, and what's the time there right now? Drop a note below. It's fascinating how this story connects us across time zones. Tracing the luminous arcs of comets through human history reveals a tapestry woven with fear, wonder, and profound meaning, where these fleeting visitors from the void have long been seen as messengers from the divine, or harbingers of upheaval. Long before telescopes pierced the night, ancient civilizations gazed upward and interpreted these bright streaks as omens, blending awe with apprehension in ways that shaped myths, decisions, and even destinies. In ancient China, for instance, comets were dubbed broom stars, believed to sweep away old regimes and usher in new eras, their appearances meticulously recorded in historical annals as signs of imperial change or calamity. The Han Dynasty chronicles, dating back over 2,000 years, detail how a comet's tail pointed toward the throne might foretell a ruler's fall, prompting emperors to consult astrologers and adjust policies in hopes of averting fate. This celestial scrutiny wasn't mere superstition. It reflected a deep cultural integration of the skies into earthly affairs, where the unpredictable nature of comets mirrored the fragility of power. As we witness the 2025 Swan, Atlas K1, Lemon, and their companions streaking across our modern horizons, one can't help but wonder, do these ancient interpretations echo in today's viral posts and whispered theories, or have we truly outgrown the impulse to seek meaning in their glow? Venturing into Mesopotamian lore, comets evoked similar dread among the Babylonians, who etched their observations onto clay tablets over 3,000 years ago, viewing these apparitions as arrows fired by gods like Marduk, signaling war, famine, or royal demise. Their priests, perched on ziggurats under starlit domes, would divine portents from a comet's direction and hew a reddish tail might herald bloodshed, while a westward path suggested foreign invasion. This predictive astronomy intertwined with religion, influencing everything from harvest rituals to military campaigns, as rulers heeded these cosmic warnings to rally armies or offer sacrifices. The intrigue lies in the parallels. Just as Babylonian scribes catalogued comets with precision, today's astronomers at the Minor Planet Center log our swarm's orbits, yet the human urge to assign significance persists. Could the clustering of 7 comets in 2025, amid global tensions, subconsciously revive these ancient fears, prompting us to scan the skies for signs of impending change in our own era? In ancient Greece and Rome, philosophers grappled with comets not just as omens, but as atmospheric phenomena, though popular belief clung to their supernatural aura. Aristotle, in the 4th century before the Common Era, theorized comets as exhalations from Earth's dry vapors ignited in the upper atmosphere, a scientific stab that influenced thought for centuries. Yet even he couldn't dispel the cultural dread. Romans saw them as divine signals. The comet of 44 before the Common Era, appearing after Julius Caesar's assassination, was hailed as his soul ascending to godhood, immortalized in coins and poetry by Virgil. This duality rational inquiry, amid mystical interpretation, mirrors our current fascination with the swarm. As Pan-stars brightens in the spring skies of 2025, one ponders, are we echoing Roman crowds, gazing at these tales and weaving narratives of transformation? Or has science fully untangled the threads of myth from fact? Across the Atlantic, indigenous cultures in the Americas imbued comets with spiritual essence, viewing them as souls of the departed or omens tied to natural cycles. The Maya, with their sophisticated calendars, recorded comets in codices like the Dresden, associating them with gods of rain and war, their appearances prompting ceremonies to appease celestial forces. In North American tribes, such as the Lakota, Comets were stars with tails, symbols of change or warnings from the spirit world, integrated into oral traditions that pass down warnings of drought or migration. This holistic view, where comets bridged the earthly and ethereal, contrasts with European conquest-era fears, where Spanish chroniclers noted Aztec Emperor Montezuma interpreting a comet in 1519 as a portent of doom, foreshadowing Cortez's arrival. The curious here is palpable. As 2025's stereo dives sunward, risking disintegration, do indigenous perspectives offer fresh lenses, seeing these visitors not as threats, but as cyclical reminders of renewal in a world grappling with climate shifts? Medieval Europe amplified comet lore into apocalyptic visions, where these hairy stars were divine judgments, as chronicled in texts like the Anglo-Saxon Chronicle, linking them to plagues, wars, and famines. The Great Comet of 1066, immortalized in the Bayeux Tapestry, appeared before the Norman conquest, interpreted as a sign favoring William the Conqueror, while dooming King Harold, a celestial endorsement that shaped historical narratives. Church fathers like St. Augustine debated their nature, but popular sermons cast them as God's wrath, urging repentance amid the Black Death's shadow in the 14th century. This era's blend of theology and observation echoes in 2025's social media frenzy, where posts tie the swarm to contemporary woes, pandemics, or geopolitical strife, reviving medieval impulses to read divine intent in the stars. Yet, the shift towards science began with Tycho Brahe in 1577, whose measurements of a bright comet challenged Aristotle's earthly origin theory, paving the way for Kepler and Newton. As Neat, our legacy comet, graces October skies, one wonders, how might Brahe's awe mirror ours, bridging eras in the quest to demystify these wanderers? In Islamic Golden Age scholarship, comets sparked intellectual curiosity alongside spiritual reflection, with astronomers like al-Biruni in the 11th century describing them as celestial bodies, their tails products of atmospheric refraction, while poets like Rumi wove them into metaphors for transient life. Ottoman records from the 15th century linked comets to events like the fall of Constantinople in 1453, blending observation with omen reading in court astrology. This fusion of empiricism and mysticism intrigues, much like today's fusion of data from the Vera Rubin Observatory with online speculations about 3I divided by Atlas's alien origins. African traditions too enriched the narrative. In Zulu lore, comets were Nkanyezi Enomsela stars, with tails portending rain or drought, integrated into agricultural cycles and storytelling. Australian Aboriginal Dreamtime tales cast them as spirits traversing the sky, their paths mapping ancestral journeys, a cultural astronomy that predates written records by tens of thousands of years. As 2025's Atlas G3 dusts the heavens, these diverse views invite reflection. Do they enrich our understanding, seeing comets as universal symbols transcending borders? The Renaissance and Enlightenment eras marked a pivot, with Halley's comet in 1682 inspiring Edmond Halley to predict its 76-year return, confirmed in 1758, demystifying comets as periodic orbiters rather than one-off omens. Yet, cultural echoes lingered. In 1758, amid the 7 Years' War, some saw it as a war omen, while others celebrated Newton's laws. The Great Comet of 1811, visible for months, coincided with Napoleon's Russian campaign, fueling prophecies of downfall. This tension science versus superstition mirrors 2025's discourse, where orbital calculations from Jet Propulsion Laboratory coexist with threads claiming the swarm signal's end times. Victorian fascination peaked with Donati's comet in 1858, inspiring art and literature. From paintings by William Dyce to poems by Gerard Manley Hopkins, portraying comets as sublime wonders. As lemon lingers in September skies, one ponders, how do these historical artworks parallel today's time-lapse videos, capturing eternal human enchantment? 20th century comets, blended spectacle with science. Halley's return in 1910 sparked panic over cyanogen gas in its tail, feared to poison Earth, leading to sales of comet pills and sealed homes, a hysteria amplified by media, much like today's misinformation on X about the swarm. Hale-Bopp in 1997 dazzled for 18 months, but tragically linked to the Heaven's Gate cult's mass suicide, believing it hid a UFO. This dark side intrigues, highlighting how comets amplify societal anxieties. In 2025, as stereo risks solar disintegration, similar fringes speculate on hidden messages, echoing past follies yet underscoring the need for education. Contemporary culture reimagines comets in media. Films like Deep Impact in 1998 depict apocalyptic impacts, while books like Lucifer's Hammer explore survival post-strike, blending fact with fiction to stoke curiosity. Music from David Bowie's Starman to classical pieces like Haydn's oratorios invoke comets as metaphors for transience. In 2025, artists inspired by the swarm create installations, like digital projections mapping tales over cityscapes, merging history with modernity. Global festivals, from China's lantern releases to European stargazing nights, celebrate these visitors, transforming ancient fears into communal joy. The swarm's cultural resonance in 2025 amplifies this legacy. Amid geopolitical shifts, some see omens, while scientists view data gold mines. Indigenous revivals, like Maori star lore tying comets to ancestors, enrich dialogues, fostering inclusive astronomy. As October peaks with multiple tales visible, the curious endures. How will this event etch into future chronicles? A blend of ancient awe and modern insight. Comets, eternal bridges between eras, continue to captivate. Their histories a mirror to our evolving gaze upon the infinite. Venturing into the realm where science meets the speculative edge of possibility, let's confront the most tantalizing question swirling around our 2025 celestial visitors. Could 3, I divided by Atlas, this interstellar wanderer streaking through our solar system, be something more than a natural chunk of ice and rock, perhaps an artificial probe sent from a distant civilization, probing our cosmic backyard? The idea ignites the imagination, doesn't it? Discovered on July 1st, 2025, by the Atlas telescope in Chile. This object, larger and brighter than previous interstellar interlopers like Oumuamua and Borisov, has already sparked debates among astronomers and enthusiasts alike. Harvard professor Avi Loeb, known for his bold theories on Oumuamua as potentially alien technology, has weighed in on 3 I divided by Atlas in recent publications, suggesting we shouldn't dismiss the possibility of artificial origins without rigorous scrutiny. Loeb points to its unusual early activity, developing a coma and tail at distances where solar heating shouldn't suffice as a puzzle worth exploring, echoing his arguments for Oumuamua's non-gravitational acceleration, possibly stemming from solar sails or engineered materials. But what if this isn't just a lone scout? What if the accompanying swarm of 7 comets, Swan, Atlas K1, Lemon, Pan-STARRS, Stereo, Atlas G3, and NEAT, forms a coordinated fleet disguised as ordinary solar system debris, arriving in unison to observe or even interact with us? The allure of this hypothesis lies in its blend of cutting-edge science and age-old human curiosity about not being alone in the universe. start with the engineering feats required for interstellar travel. Any artificial probe, like 3i divided by Atlas, would need to conquer distances measured in light years, enduring cosmic radiation, micrometeoroid bombardments, and the relentless void. Propulsion alone poses a monumental challenge. Chemical rockets fall woefully short, demanding breakthroughs like nuclear pulse drives, antimatter engines, or even theoretical warp bubbles that bend space-time. Loeb, in his discussions on interstellar objects, highlights how solar radiation pressure could propel thin, lightweight sails across the galaxy, much like the Breakthrough Starshot initiative aims to send gram-scale probes to Alpha Centauri at 20% the speed of light. For 3i divided by Atlas, its hyperbolic trajectory racing in from Perseus at 26 kilometers per second fits a passive drift model. But imagine if subtle course corrections, undetectable at our current resolution, guided it here. Navigation would require star maps precise over geological timescales, perhaps using pulsars as galactic beacons, pulsing with millisecond accuracy to triangulate position across the Milky Way. Yet, the data so far leans natural. NASA's confirmation on July 15, 2025, via Hubble imagery, estimates its nucleus at several kilometers, with spectra dominated by carbon monoxide and methane, exotic but explainable for an object from a colder stellar nursery. No anomalous signals detected by SETI protocols, which scan for radio or optical emissions across frequencies, rule out obvious beacons. But what if communication hides in subtler forms? Hypothetical scenarios get playful here. Perhaps neutrinos, those ghostly particles zipping through matter undetected, carry modulated messages, or quantum entanglement links it to a home base instantaneously, defying light speed limits in ways our physics only theorizes. Loeb's work on Oumuamua speculated similar, its flat, tumbling shape, possibly a light sail, accelerated without outgassing. For 3i divided by Atlas, its premature coma might mask thrusters, vaporizing ices to mimic natural activity while providing thrust. The curious builds. If artificial, what mission drives it? A scientific survey, mapping habitable zones, or something more ominous, like reconnaissance for resource extraction? Extending this to the swarm elevates the speculation. Envision these 7 comets as a distributed network, each a node in an alien array, their arrivals timed to triangulate Earth's position or scan for biosignatures. Swan, with its hydrogen glow detected by the Solar Wind Anisotropies instrument on September 12, 2025, brightens to magnitude 7.5 by October. Could its envelope hide sensors probing our atmosphere? Atlas K1, perihelion on October 8th at 0.3, at 3 astronomical units. Risks solar disintegration, perhaps a sacrificial probe, designed to fragment and disperse nanomachines into the solar wind. Lemon, reaching magnitude 7 and lingering through October, positions mid-swarm as if coordinating data relay. The engineering implications stagger. Camouflaging as comets requires mimicking spectra, water, ice, carbon dioxide, silicates, while embedding tech resilient to cosmic rays. Power sources, perhaps zero-point energy harvesters or microfusion reactors, theoretical but within advanced civ's grasp per Kardashev scales. Loeb's theories on interstellar artifacts emphasize evidence thresholds. Anomalies like Oumuamua's acceleration without visible outgassing warrant investigation, not dismissal. For our fleet hypothesis, orbital diversity challenges coordination. Diverse inclinations and eccentricities suggest independent origins. but an advanced sender could launch from varied points, syncing via onboard AI. Hypotheticals delight. Communication via gravitational waves, rippling space-time subtly, or entangled particles for instant relay. SETI's scans of 3I divided by Atlas since July yield silence. But as Loeb notes, aliens might use unfamiliar bands, optical lasers pulsing in prime number sequences or infrared bursts mimicking stellar noise. Backbore comes from hard data. Natural compositions per Hubble spectra. No emissions per breakthrough. Listen. Orbits fitting Oort cloud ejections. Yet, Loeb's Pacific expedition for Oumuamua-like fragments in 2023 found magnetic spherules he claims interstellar, fueling debate on artificial meteors. For 2025, if swarm fragments yield odd alloys, it could tip scales. Strategic logic questions. Why disguise? Overwhelming tech negates need, unless stealth scouts for non-interference ethics, like Star Trek's Prime Directive. Cultural appeal roots in isolation anxieties. Fermi paradox asks, where is everybody? Making probes a hopeful sign. Loeb's book Extraterrestrial argues Oumuamua's odds favor artificiality, urging open minds. Hypotheticals. Swarm as von Neumann probes, self-replicating, harvesting resources to build more, or biological engineered organisms in icy shells. Evidence standards remain high. Extraordinary claims need proof signals, anomalies beyond nature. Current observations favor natural. 3I divided by Atlas as ancient comet, swarm as statistical fluke. But as October nears, closer scrutiny via James Webb might reveal TELS irregular rotations or spectra quirks. The joy is in the pursuit. Probing these ideas expands horizons, reminding us the universe might hold intelligences whose tech dwarfs ours, or simply wonders that spark our own ingenuity. As the whispers of alien probes and coordinated fleets echo through online forums and late-night discussions, it's impossible not to confront the darker shadows they cast. The chilling notion that our 2025 comet swarm might herald not just wonder, but outright catastrophe, a doomsday scripted in the stars, or a stealthy invasion unfolding before our eyes. Imagine the scenario painted in vivid apocalyptic strokes. 7 comets plus the interstellar outlier 3I divided by Atlas. Not as random wanderers, but as harbingers of Armageddon, their icy bodies concealing payloads that could shatter civilizations or signal an extraterrestrial armada's advance. This narrative, fueled by a mix of historical fears and modern anxieties, grips the imagination like a thriller unfolding in real time after all. What if the bright tales streaking across October's skies are the opening salvos of something irreversible? Yet, as we peel back these layers with a blend of scientific scrutiny and open-minded curiosity, the truth emerges not in flames of destruction, but in the calm reassurance of orbital mechanics and probabilistic reality, leaving us to ponder why such tales persist even as evidence mounts against them. The doomsday script often begins with the raw terror of impact. Visions of comets like Atlas K1 plunging sunward on October 8th at a mere 0.33 astronomical units, suddenly veering off course to slam into Earth with the force of 1 million nuclear bombs, extinguishing life in a global winter of dust and darkness. Hollywood has primed us for this. Think of films like Armageddon or Deep Impact, where heroic efforts avert extinction-level events. But let's ground this in the unyielding math of astronomy. NASA's Near-Earth Object Program, updated as of September 20th, 2025, tracks these bodies with laser precision, and none of the Swarm, Swan, Lemon, Pan-STARRS, Stereo, Atlas G3, NEAT, or even the Swift 3I divided by Atlas comes closer than millions of kilometers to our planet. Atlas K1's trajectory, refined through thousands of observations from the Jet Propulsion Laboratory's Horizons system, maintains a safe perihelion far from Earth's orbit, its path locked by gravity's inexorable laws, without room for dramatic swerves. The odds of any comet altering course mid-flight? Virtually zero, barring some exotic force we've yet to detect, like a hidden thruster or quantum anomaly, speculations that thrill but crumble under scrutiny, as no such deviations appear in the data from global telescopes, like those in the Pan-STARRS network. What fuels this apocalyptic allure, then? Perhaps it's rooted in our species' deep-seated pattern-seeking, where clustering, like this swarm's 7 bright comets in a narrow window, feels too orchestrated to be benign, echoing biblical tales of fiery judgments, or ancient prophecies of world-ending skies. Online threads on platforms like Reddit, buzzing since the swarm's announcements in early 2025, weave narratives of biblical signs, linking the comets to Revelation's wormwood star poisoning waters, or Mayan end times calendars. One viral post from July, amassing over 50,000 upvotes, claims the alignment mirrors Nostradamus' quatrains, predicting 7 fiery messengers heralding chaos. But delve deeper, and these dissolve. Statistical models from the International Astronomical Union simulate comet arrivals over millennia, showing clusters like this occur roughly once every 500 to 1,000 years. Pure chance in a vast, random solar system. No need for divine wrath or cosmic curses, just the elegant chaos of Oort cloud perturbations, where distant stellar flybys every few million years dislodge batches of icy bodies, sending them inward in sporadic waves. Still, the invasion angle adds a layer of insidious intrigue, positing the swarm not as destroyers, but as disguises. For an alien incursion, each comet, a Trojan horse, cloaking probes that could deploy drones, scan for resources, or even seed nanotechnology into our atmosphere. Picture stereo, the solar grazer risking disintegration in October as a deliberate sacrifice, fragmenting to release swarms of micro-machines that hitch rides on solar winds toward Earth. Or 3i divided by Atlas with its hyperbolic escape trajectory as the command module, coordinating via undetectable signals while the locals like Pan-STARRS provide cover with their familiar compositions. This scenario draws from thinkers like physicist Freeman Dyson, who in the 1960s envisioned alien civs building megastructures, or SETI pioneer Frank Drake, whose equation estimates thousands of communicative societies in our galaxy. If advanced enough, they could engineer comets with metamaterials that mimic spectra water ice laced with silicates, while embedding quantum computers resilient to the void's rigors. The psychological pull is undeniable. In an era of uncertainty, with climate crises and AI advancements reshaping reality, these theories offer agency to the unknown, transforming passive stargazing into a narrative of hidden threats. A study from the Pew Research Center in 2024 found over 40% of Americans believe in extraterrestrial visits, a sentiment amplified by 2025's events. Posts on X from September 10th claim comet anomalies like unusual brightness, fluctuations in SWAN as engine tests, garnering millions of views. Misinformation thrives here. One conspiracy site, citing unverified leaked NASA docs, alleges orbital histories fabricated to hide artificial origins, ignoring the decades of archived data from surveys like Catalina, which tracked NEAT since the early 2000s without anomalies. Backbore begins with the camouflage conundrum. Forging 7 comets to pass as natural would demand godlike precision-matching isotopic ratios in their tails, as revealed by Hubble spectra in August 2025, which show standard solar system abundances of deuterium and carbon-13. Any artificial core would leak tells. Irregular heat signatures from power sources, detectable by infrared scopes like the James Webb, or non-gravitational accelerations beyond outgassing norms, as measured in Oumuamua but absent here. Logistics defy reason. Launching such a fleet across light years requires energy budgets, eclipsing our global output. For what gain? If aliens possess interstellar travel, why the ruse? Strategic irrelevance looms overwhelming. Tech would negate stealth, unless motives are inscrutable, like ethical non-interference or psychological experiments on primitive species. Compare to real existential risks, and the contrast sharpens. Climate change, with IPCC reports from 2023 projecting sea level rises displacing hundreds of millions by 2050, poses tangible doom without cosmic intervention. Or AI, where experts like those at the Future of Humanity Institute warn of misalignment leading to uncontrolled superintelligences by mid-century. Pandemics, nuclear proliferation, these ground our fears in evidence, unlike comet conspiracies, which distract from actionable threats. A 2025 paper in Nature Astronomy debunks impact panics, noting deflection tech, like NASA's DART mission, successful in 2022 against Dimorphos, could redirect hazards years in advance. Yet, the curious persists. What if fragments from Stereo's potential breakup in October yield meteors with anomalous compositions, sparking re-evaluation? Or if SETI detects bursts during the swarm's peak, timed to solar flares for cover? Protocols from the International Academy of Astronautics outline responses to such signals. Quarantine data, global consultation, reminding us preparation fosters hope, not dread. Historical hoaxes add flavor. The War of the Worlds broadcast in 1938 panicked thousands with faux Martian invasion reports, mirroring today's swarm memes. Or the 1910 Halley hysteria, with comet pills sold against tail gases, cyanogen detected but harmless at distance. These caution against overreach, yet inspire. 2025's events could pivot public interest toward space defense, funding missions like the Near-Earth Object Surveyor Telescope, launching in 2028, to catalogue threats. In debunking, beauty emerges. The swarm as a natural marvel, not menace. Their orbits a testament to solar system's ballet. No invasions needed when reality offers interstellar visitors like 3I divided by Atlas, its methane tail a bridge to alien chemistries. As October unfolds, with Lemon lingering and Swan fading, the true invasion might be of knowledge, citizen data flooding in, unraveling mysteries without apocalyptic scripts. The narrative's endurance speaks to our psyche. Evolutionary wiring, spots, patterns in randomness, turning coincidence into conspiracy for survival's sake. Cognitive scientists at Yale note confirmation bias amplifies this, where swarm posts on X reinforce fears, algorithms pushing similar content in echo chambers. Education counters. NASA's outreach in 2025, with virtual reality swarm tours, demystifies while enchanting. Ultimately, these scenarios' doomsday, crashes, or veiled incursions crumble under evidence's weight. Yet their exploration enriches us, sharpening skepticism and wonder. Real risks like asteroids demand vigilance. The Torino scale rates our swarm at 0, no concern, but inspire planetary defense, like the UN's Space Mission Planning Advisory Group. As NEAT peaks in October, perhaps the greatest revelation is internal. Our capacity to dream darkly, then illuminate with reason. As the luminous trails of our 2025 comet swarm begin to fade from the night sky, leaving behind a legacy etched in starlight and human curiosity, we're left to reflect on the profound message woven into this celestial tapestry, a reminder that the universe operates on scales of chance and wonder, where even the most improbable alignments can spark transformative insights without needing hidden agendas or cosmic conspiracies to explain them. Picture the journey we've traversed, from the initial thrill of spotting Swan's hydrogen glow on September 12th, captured by the solar wind anisotropies instrument aboard a sun-studying spacecraft, to the daring solar grays of Atlas K-1 on October 8th, its nucleus potentially fracturing under intense heat to reveal primordial secrets. These visitors lemon lingering through October with its dusty arc, Pan stars inviting springtime gazes, Stereo risking disintegration in a blaze of plasma, Atlas G3, showcasing the precision of Hawaiian surveys, and Neat as the steadfast legacy from early 2000s tracking have converged not by design, but through the elegant randomness of orbital mechanics, a statistical fluke where paths set eons ago intersect in our fleeting moment. Yet, this coincidence, rare as it is, models suggest such bright clusters grace our skies. Perhaps once every 500 years carries a deeper resonance, urging us to question what unseen rhythms in the galaxy's vast choreography might make these gatherings feel so serendipitously timed. And how might they reshape our understanding of the cosmos? At its core, this swarm whispers of the universe's indifference to our narratives, a natural phenomenon born from the Oort cloud's distant perturbations, where gravitational whispers from passing stars dislodge icy relics in sporadic waves, sending them sunward on journeys spanning millennia. The data tells a story of independence. Each comet's spectrum, analyzed through Hubble's gaze since July, reveals standard solar system compositions, water ice sublimating into jets for Swan, carbon dioxide dominating Lemon's makeup, without the exotic anomalies that would hint at artificial meddling. No shared perturbations distort their paths, as confirmed by Jet Propulsion Laboratory ephemerides updated through September. Instead, they embody the poetry of probability, where the improbable becomes inevitable in an infinite expanse. But herein lies the curious. If this is mere chance, why does it coincide with solar maximum's magnetic fireworks? Cycle 25, peaking with sunspots exceeding 130 in August, amplifying tails into kinked spectacles that seem almost responsive? Perhaps the message is one of interconnectedness, not orchestrated, but emergent, where solar winds and galactic tides subtly tune the influx, hinting at cycles we've only begun to chart. The scientific design of this event unfolds like a gift unwrapped over months, offering unprecedented opportunities for comparative cometology that could redefine our grasp of solar system origins. With 7 bright comets sharing the stage, Swan reaching magnitude 7.5 by October, visible near Mars in the western twilight, and Atlas K-1 potentially flaring dramatically as it skims 0.33 astronomical units from the Sun, we gain a rare laboratory in the sky. Researchers at institutions like the Max Planck Institute are already poring over spectra from ground-based arrays in Chile, comparing volatile outgassing rates. Swan's rapid hydrogen envelope suggests a fresh, volatile-rich nucleus, while Neat's subtler glow points to an aged, crusted surface. Evolutionary stages captured in one season, this bounty could illuminate the Oort cloud's diversity, perhaps revealing how Neptune's resonances sculpt comet families over eons, or how cosmic rays etch isotopic signatures that trace back to supernova remnants seeding our primordial disk. The curious escalates with 3I divided by Atlas's inclusion. Discovered July 1st by the University of Hawaii telescope, this interstellar comet, potentially the oldest we've seen, with activity starting at 670 million kilometers from the Sun, offers extrasolar contrasts, its methane and carbon monoxide emissions hinting at formation around a red dwarf star, challenging models of planetary nurseries beyond our own. What if its chemistry holds keys to universal life-building blocks, preserved across light years? Educational ripples extend far beyond labs, transforming this swarm into a global classroom that ignites public passion for the stars. Schools worldwide are integrating the event into curricula. In Australia, students track SWAN via apps like StarWalk, logging brightness changes to learn orbital predictions, while European planetariums host virtual tours blending real-time feeds from Unistellar's Citizen network with historical comet lore. This democratization of discovery, amateurs contributing via EVscope since September, capturing time-lapses of multiple tails against auroral backdrops, fosters a sense of shared exploration where backyard observers in India or urban stargazers in Tokyo become co-authors in unraveling cosmic puzzles. The intrigue lies in its timing. Amid a digital age where misinformation spreads like solar wind, this swarm counters with tangible science, teaching critical thinking, discerning natural flukes from contrived plots. As posts on X, from September 17th, link comets to galactic DNA impacts or earthquakes, only for data to reveal solar flares as the true culprits. Perhaps the design is a renewed humility, reminding us that curiosity over fear drives progress, turning potential panic into planetary unity. Looking forward, the swarm's influence propels future missions that promise to unlock even greater mysteries. Europe's Comet Interceptor, slated for launch in 2029, draws inspiration from this event. Designed to rendezvous with a long-period comet like those in our swarm, it could sample pristine ices mid-flight, analyzing organics that mirror life's precursors. NASA's ambitions amplify. Concepts like the Near-Earth Object Surveyor Telescope, advancing toward 2028 deployment, aim to catalog threats but also map Oort dynamics, potentially forecasting future clusters. The curious surges with 3I divided by Atlas's implications. As it slings past perihelion on December 15th, its hyperbolic exit could inspire interstellar probes like Breakthrough Starshot, accelerating tiny sails to nearby stars by 2030. What undiscovered siblings await detection? Estimates suggest thousands of interstellar objects traverse our system yearly. Most unseen 2025's catch, confirmed by NASA on July 15th, underscores our improving vigilance from Vera Rubin's high-cadence scans to AI-driven anomaly hunters. This could herald an era of routine interstellar encounters, reshaping astrobiology. Imagine sampling alien ices for biosignatures, or tracing their origins to systems like TRAPPIST-1. Culturally, the swarm etches a new chapter, blending ancient awe with contemporary creativity. Artists worldwide respond. Digital installations in Tokyo project tales over skyscrapers, while musicians compose symphonies echoing Solar Maximum's plasma hums, inspired by Swan's glow near Mars. Literature blooms novels, weaving the swarm into tales of unity, countering doomsday tropes with themes of resilience. Global festivals, from Chile's stargazing retreats to India's Diwali sky watches, celebrate this as a shared heritage, fostering cross-cultural dialogues on humanity's place amid the stars. The intrigue. How will this event echo in folklore a century hence? Perhaps as the year of 7 messengers, symbolizing renewal amid uncertainty. Economically, the design sparks innovation. Tourism surges with dark sky reserves, like those in New Zealand, hosting swarm viewing events, boosting local economies while promoting conservation. Tech firms develop augmented reality apps, overlaying orbital paths on live views. educating millions. Philanthropy follows funds like the planetary societies, bolstered by 2025 donations, accelerate comet research, potentially yielding breakthroughs in material science from studying volatile sublimation. Environmentally, the swarm subtly influences heightened awareness of space weather, amplified by Cycle 25's flares, drive sustainable tech-hardened grids against geomagnetic storms, echoing Quebec's 1989 blackout lessons. This ties to broader stewardship. Comets as reminders of our fragile biosphere, their organics hinting at panspermia's role in seeding life, urging protection against anthropogenic threats. Philosophically, the message resonates. In a universe of trillions of stars, our swarm underscores serendipity's beauty, where coincidence fosters discovery without malice. The curious endures what future alignments await, and how might they challenge our solitude? As 2025 wanes, with Lemon's arc dimming and 3I divided by Atlas, vanishing into the void, the D-San endures, a call to embrace the unknown with open eyes, turning fleeting lights into enduring enlightenment. Yet, loose threads tantalize. Unresolved anomalies in 3I divided by Atlas's early activity, methane bursts defying models, invite re-evaluation, perhaps a hybrid origin, natural yet influenced by unseen galactic forces, or the swarm's clustering, within statistical bounds but edging improbability, hinting at undiscovered resonances. Future data from Comet Interceptor or Rubin's surveys could unravel these promising revelations that keep the wonder alive. In closing, this swarm's true gift is perspective. A vast universe, indifferent, yet brimming with invitations to explore. It teaches that curiosity, not fear, illuminates the path forward, transforming 2025 skies into a beacon for generations, where coincidence becomes catalyst and the stars whisper endless possibilities. If you've enjoyed unraveling this cosmic story with me, why not hit subscribe and enable those bell notifications? That way, you'll catch every new episode as we dive deeper into the unknown together.